Hello everyone, we are starting section 7.3 today. This is the last section of chapter 7, and it's a third type of confidence interval. This is a confidence interval for a proportion. So for the first two sections, we were trying to find a confidence interval for the population mean, but what if we're not working with an average, but we're working with a percentage? This is where this confidence interval is going to come into play. And also a formula. We're going to finish notes on the calculating the sample size tomorrow after the quiz. So let's take a look at all the notation that's involved here and just different facts, different assumptions that we're going to need throughout this section. So inferential statistical techniques have various assumptions that must be met before valid conclusions can be obtained. And this is what we've seen throughout the course so far. Dealing with how samples are selected, we always want them to be random. Sample size, which is n, needs to be greater than or equal to 30, or the population must be normally or approximately normally distributed. Some statistical techniques, though, are what we call robust. And this means even though the distribution is maybe not considered to be normal, or we say it can depart somewhat from normality, valid conclusions can still be obtained. So we'll say the distribution, just abbreviate that here, can depart somewhat from normality, and valid conclusions can still be obtained. All right, so let's take a look at an example where we're getting proportions from. What kind of a situation would cause us to use this type of confidence interval? So this is an example. A USA Today snapshots featured stated that 12% of the pleasure boats in the US were named Serenity. So the parameter, we're not looking at a population mean anymore, but the parameter of 12% is the proportion. So depending on the sample size, we could just make this very basic. What this really means is of all the pleasure boats in the US, 12 out of every 100 are named Serenity. This could be kept as the 12%. It could be the 0.12, or it could be a fraction, anything that calculates to 0.12. So proportions, percentages, are the same as probabilities. All connected here. Because in this case, we're talking about a name of a boat. We're just counting up kind of like a categorical, but we're getting a tally here. So let's take a look at all of the new symbols, the new notation we're going to use with this confidence interval. So proportions can be obtained from samples or populations. So instead of using mu, because mu is representing the population mean, we use P. This is the population proportion. So this is the biggest difference. This is what's going to go in between the inequality symbols versus a mu. or it's also called the true proportion. So you could use either one of these phrases. Now, just as with sample means we had X bar, this is going to be the sample proportion. We call this P hat. So it has like a little caret symbol over it, like it's wearing a little hat. And this is the sample proportion. Now, anytime we dealt with percentages, we always took the complement. Whenever we had a P, we had a Q. So we also have a Q hat. And it doesn't really have a name other than it being the complement, but it's just equal to 1 minus P hat. And it's going to show up in our formula. Now, how do we calculate P hat if it's not already given to us? It's simply equal to the number of data values we're looking for out of the whole sample, because it's just that, like the 12 out of 100. So again, X is equal to the number of sample units that possess the characteristics of interest. Just like when we were looking at the binomial distribution, the number of successes was P. Same thing here. And of course, N is the sample size. All right, so first we're going to do just a few examples of calculating P hat and Q hat. So here's our first example. In a study, 200 people were asked if they were satisfied with their jobs or professions. The results were that 162 said they were. We're going to find P hat and Q hat, where P hat, and this is what we always want to keep in mind, what is P hat representing? So P hat is the proportion of those surveyed who were satisfied with their jobs or professions. So those that said yes. So pause the video to still copy that down. So again, P hat is equal to X over N. So this would just be the 162 that said yes out of all 200. And then we could turn this into a percent. We could turn this into a decimal. Let's turn it into a decimal. Just simplifying that is the same as 81 over 100. So we're getting 0.81. And then that makes Q hat the complement, which would be 0.19. And that's all we were asked to find here, P hat and Q hat. All right, another example. In a recent survey of 150 households, 54 had central air conditioning. I want you guys to pause this to try this now. Find P hat and Q hat, where P hat is the proportion of households that have central air conditioning. Pause the video if you need more time. But we always still want to show what we're calculating here. So P hat would be the 54 over 150. And then this turns out to be 0.36. Q hat is a complement. 1 minus 0.36 is giving us 0.64. So in these first two examples, we were just given the data of how many met that characteristic or had that characteristic we were looking for out of a total. Sometimes the problems are going to already give us a percent. So in this case, find P hat and Q hat for each percentage. So when we're given a percentage, that is P hat. So So it's actually even easier than what we were just calculating. So for part A, this just means p hat is 0.72, which makes q hat 0.28. So somebody already calculated a fraction to turn it into a decimal for us. That gave us this percent. For B, this just means p hat is 0.15 and q hat is 0.85. And this is just to show us that when we're reading a situation or little paragraph scenario and the percentage is already given to us, p hat is that percentage and q hat is the complement. All right, so let's take a look at how this confidence interval is going to be different than what we've done in the past. So this interval for p, which is the true proportion, is based on the sampling distribution of p hat. Now this isn't anything I'm going to quiz you over, it's just some background information. When the sample size n is no more than 5% of the population size, then we could kind of say the sampling distribution of p hat is approximately normal. All right, so now let's take a look at the formula. Now with this, we are back to the z distribution. And p, the true proportion or the population proportion, goes in the middle. So we start, instead of with x bar, we start with p hat minus z sub alpha over 2. But because there's no standard deviation here, it's multiplied by the square root of p hat times q hat over n. So this z sub alpha 2 times this radical, that's the margin of error. And then we have p hat plus z sub alpha over 2 times the square root of p hat times q hat over n. And two assumptions here. What we part of what we mentioned at the very beginning, that the sample is a random sample. And then how I mentioned earlier that this is tied into the binomial distribution or binomial experiment for successes versus failures. The condition for a binomial experiment are satisfied. Now this has a slightly easier rounding rule. If you remember back to all the rounding rules before where we were calculating probabilities, we said as long as you round to 2 or 3 decimal places, you're good. So the same thing is true here. And we'll just kind of keep it with 3. Now, when we go to answer the statement for our confidence intervals, it's going to change a little bit because instead of using population mean, we're going to say true proportion. So again, the template is 1 can be whatever percent we're looking for, confident. You could either say that the population proportion or true proportion is between whatever 2 values we're getting. And again, we can leave them as percentages or decimals. So let's just take a look at two examples, and that'll wrap up today's lesson. All right, so pause the video to copy this down. And here we have a survey conducted by Sallie Mae and Gallup of 1,404 respondents, found that 323 students paid for their education by student loans. We want to find the 90% confidence of the true proportion of students who paid for their education by student loans. So first we need to calculate p hat. And just as we did for our very first two examples, that's going to be the 323 out of 1,404. And then for this, let's just round to 2 decimal places. So we should be getting a 0.23. That means Q hat is going to be the complement of 0.77. Next, we need to find the Z sub alpha over 2 for the 90%, which we should have that listed, but if not, you can go ahead and calculate that. Remember, that's going to be menu 553 on the calculator. Alpha over 2 should be 5%, so we should be getting a 1.64. All right, so as we go to set this up, remember P is in the middle. So we're going to have the 0.23 minus the 1.64 times the square root of 0.23 times 0.77 divided by the 1,404. That's our sample size. And on the other side, we'll have 0.23 plus 1.64 times that square root. So go ahead and calculate those. Again, we'll round to 3 decimal places. All right, pause the video if you need more time, but the lower number should be a 0.212, and then the upper value should be a 0.248. So there's our confidence interval. And again, I'm just going to say the statement out loud, so just know how to write it. We're just going to say one can be 90% confident that the true proportion, and technically we're talking about students who pay for their college education by student loans. So we could say, again, one can be 90% confident that the true proportion is between 21.2 and 24.8%. Keep in mind what the proportion is indicating here, and that's the percentage of students that use student loans to pay for college. And let's try one more. All right, so pause the video to copy this down. All right, this example is giving us that a survey of 1,721 people found that 15.9% of individuals purchase religious books at Christian bookstores. We're going to find the 95% confidence interval of the true proportion of people who purchase their religious books at Christian bookstores. So if you notice here, even though we're given a total, the percentage is already calculated for us. Now when it is, we're going to round as a decimal just to take it out as many decimal places here. So we don't want to turn this into 16%. We're going to leave p hat at a 0.159. That means Q hat should be a 0.841. And again, we need to find Z sub alpha over 2. We're at a 95% confidence interval. and this is the one we're dealing with, the 1.96. Let me just fill in the formula. So our true proportion is between 0.159 minus 1.96 times the square root of 0.159 times 0.841 over the 1721. Again, go ahead and calculate that. Again, rounded 3 decimal places, so pause the video if you still need more time. But for the lower value, we should be getting a 0.142, and the upper value a 0.176. So it sounds better if we turn these back into percentages at the very end for the statement. So again, this time we could say, one can say with 95% confidence that the true proportion is between 14.2 and 17.6%. All right, so be sure that you're preparing for your quiz tomorrow over section 7.1 and 7.2. We just have a few more examples to go through from 7.3, so I'll have another video lesson posted tomorrow finishing up section 7.3 notes. I may already assign the worksheet, but then still give you Wednesday to work on it, but we have to still go over sample size. So let me know if you have any questions.